You know, they say when you shoot for the moon, even if you miss, you land among the stars. But today, we are lucky because we have someone with us who actually worked on a mission that touched the moon.
That's right. Gopalan International School, in collaboration with the Ninad Foundation, proudly welcomes you all to this special session with a distinguished personality, Ms. Tanuja Patki ma'am, from the Indian Space Research Organization, Bangalore, a scientist who has contributed to the historic Chandrayaan-3 mission.
Before we begin, let us extend a heartfelt welcome to everyone present here today. Our guest of honor, Ms. Tanuja Patki ma'am, Dr. Anurag Livekar sir, our esteemed dignitaries, our dear parents, our respected principal, Ms. Rajashri Nitin Chaudhary ma'am, the enthusiastic students of Gopalan Engineering College, Gopalan PU College, and our very own GIS family. We are truly delighted to have each one of you here with us today to celebrate this special occasion together.
With such a gathering of brilliant minds and warm hearts, we are certain that this morning will be filled with knowledge, inspiration, and dreams that soar higher than the skies and deeper than the universe.
To begin this occasion, I request our dignitaries to kindly come forward for the traditional lamp lighting ceremony, symbolizing wisdom, knowledge, and enlightenment. Stand up, please, all of you. Thank you. May I now request our guest of honor, Ms. Tanuja Patki ma'am, Dr. Anurag Livekar sir, and our principal, Ms. Rajashri Nitin Chaudhary, to grace the stage for a brief felicitation.
It is my privilege to introduce Dr. Livekar sir, a distinguished consultant in medical gastroenterology with over 15 years of expertise in gastroenterology and hepatology. Having earned his MBBS, MD in general medicine and DM in medical gastroenterology, Dr. Livekar sir has dedicated his career to excellence in healthcare. We are truly honored to welcome you today, sir, as you also represent the Ninad Foundation, a non-profit organization committed to empowering underprivileged communities and driving positive social change. May I now request Principal Ma'am to kindly felicitate Sir with a bouquet as a token of gratitude.
esteemed guest of honor, a distinguished scientist at ISRO, Tanuja Ma'am has been an integral part of India's landmark Chandrayaan-3 mission, a proud achievement that has placed our nation at the forefront of space exploration. With over 18 years of experience in space research and technology, she stands as a true inspiration for young minds, particularly students who dream of reaching for the stars. Her dedication, perseverance, and contributions to our country's progress remind us that with vision and hard work, the sky is not the limit, but only the beginning. We extend a very warm welcome to you, ma'am. May I now request Principal Ma'am to kindly felicitate Miss Tanja Patki Ma'am with a bouquet and a memento for
allowing us to organize today's program in their premises. I will not take much of your time and brief you shortly about the Dina Foundation and Dr. Shantanu Ambedkar. We are running Dina Foundation in the fond memory of our beloved friend Dr. Ninath Baswadekar. He was a promising oral surgeon from Nanded, my hometown. We lost him to a massive heart attack when he was hardly 30 years old. We have been running our organization for last 10 years in the fields of health and education. We are running annual blood donation camps, running charity clinics, distributing gumboots to farmers, and spreading awareness to prevent snake bites, and providing school supplies to poor kids in rural parts. We have adopted a roadside school in village named Kundba called Palavarchi Shala in Marathi. Today's event is also one of the undertakings of the Ninath Foundation. It is being held in memory of Dr. Shantanu Ambedkar. He was a gynecologist, a rationalist, a writer, and a naval science enthusiast. He passed away last year, bravely battling lung cancer for over 2 years. I shared a good rapport with him. Ninath Foundation decided to commence a yearly series of orations or Vyakhyan Mala in his memory. I am grateful to Madam Tanuja Patki for her spontaneity and readiness for this session without any second thought. Tonight she is flying to US and today morning she is with us. That itself speaks volumes about her commitment to the cause. I also thank Shri Sripaji Ghate and Shri Tushar Bhatt, without whom it would be impossible for me to embark on this journey of organizing programs in Bangalore. Today is the National Space Day, and I am happy that we could organize this event on National Space Day. Without further ado, I will request Madam Tanuja Patki to enlighten all of us on achievements and prospects of India in space research. I understand that sky is not the limit, and we are all going to enjoy it. This is going to be an interactive session. It will be a very lively session. Madam is open for discussion, open to take questions. So, she has worked in ISRO and she herself has a first-hand experience of working in successful launch of Chandrayaan-3 Mohin. She is a very great scientist. At the same time, she is very friendly with all of you. Feel free to ask questions whenever you feel like. I request Madam to take over now on. Thank you.
Thank you, sir. May I now request our Principal Ma'am and Dr. Navekar sir to kindly take their seats among the audience as we hand it over to our distinguished speaker, Ms. Tanuja Patki Ma'am. Friends, this is indeed a moment of pride for all of us. Let us all welcome Ma'am with the warmest round of applause as she takes the stage.
Just before I hand over the mic to our guest, I would just like to invite and welcome the PUC Principal, Ms. Sangeeta Ma'am,
And thank you for bringing in your students for this session. And I'm sure it's going to be an enriching session. Thank you.
Good morning all. Am I audible till the end? Are you able to hear me properly? Yes. So happy National Space Day and good morning. I am really happy to see the energetic and enthusiastic faces today early in the morning. For us this is a rare scenario and I think this is the magic of school. And before starting the lecture, I would like to thank Dr. Ninad and Dr. Anurag for Ninad Foundation and your principal Madam Gopalan International School because we don't get to see such fresh faces. So I am really feeling very happy. And though I like to interact with young kids, I usually restrict myself because of other priorities or limitations. But he constantly persuaded and convinced me that how kids need the inspiration and how they must know about this field. So I am here today in front of you. So before starting the lecture, thank you Dr. Anurag, thank you Principal Ma'am, and thank you all for coming because if I prepare something for you and if you are not there, I will not be happy. And the thing is, this will be the interactive session. Now today is National Space Day, so we should enjoy the day. We should celebrate being in space, India being in space. So I may be asking some things to you, and if you are able to answer, if you are able to try, give it a chance, then you can come and pick up something, whatever you like from the table. It is open to you, anything you can pick up. And most enthusiastic person you have let Principal Madam choose who should get the book gift. Is it okay? Yes or no? Or you want someone say who is your favorite teacher? Who? Everybody will have different favorites. Oh, own favorites. Okay. Then I am choosing because my favorite is Principal Madam. I have to get introduced to other maths. Okay. So can we start? So when we say today's lecture topic is sky is not the limit. The story beyond the sky is fascinating. It holds breathtaking wonders of graceful cosmic dance. So if you want to think about what lies beyond the sky, first we should know where we are today. We means India. Where we are we progressing? How is India now? What do you feel? India is underdeveloped country or developing country or developed country? One person, I am not able to hear. Developed? Sure? Developing country, okay. So where are we today? What is India's rank in research? Are you aware of? Who is the top one in research? Okay, you may not be in the field directly in research, but which countries have most products? USA, China. So India will come in third or fourth land. Though if you see our researchers or the people working in USA, they are in top ranks, correct? Our CEOs in US companies are, most of them are Indians. Do you agree with this? Then why India is not there in top rank? Okay, we will see. So, what is this? We started with, can you tell me some ancient Indian scientists? Our science is having very nice Vedic. Aryabhatta. Okay, who was Aryabhatta?
He was a mathematician who invented zero.
Then what Brahmagupta did?
I don't know.
Okay, there is a confusion between Aryabhatta invented zero or Brahmagupta invented zero. but the logic of zero is with Brahmagupta, also with Aryabhatta. Then who was Sushruta? Tell me.
Father of surgery.
Shabbas. Anyone else? Who was in astronomy? You said Aryabhatta, okay. And who was from Ayurveda? Who invented Ayurveda? Yes, anyone can answer. Charaka. Charaka Samhita, you know? So he was a physician and Ayurveda. So our ancient Indian science, if we say the established science started with Ayurveda, then now today if you see, initially we used to say remote places, villages, they don't have access. Today our farmers can get the data whether it will rain, meteorological data, whether it will rain or not, whether I should plant this crop or not, directly by mobile or radio, they get the data what they should do in their farms. Now many foreign country patients are coming to India because of the medical expertise available in India. Then many young innovators are using robotic solutions for solving the problems, solving real life problems, correct? Then for research in genetics and virology is now at peak. We have provided COVID time we have provided to all over world, correct? And you have to answer who is this? Who is this person? Come here. Take it from there. You are right. Today, our Indian astronaut, Group Captain Shubhanshu Shukla, he is the first person to live and work in International Space Station. So this is very rare that Indian person is going in US and going to International Space Station, staying there, working with those people. So we are progressing there. And who was the first astronaut, Indian astronaut? He was the wing commander, Mr. Rakesh Sharma. Wing commander Rakesh Sharma was the first Indian astronaut. He went in space and came. Shubhanshu Shukla is the second astronaut who went to space. And this is, now we are establishing the career in space. Our people, we are telling tomorrow, you don't know, when we were young, we were not having mobiles. So we used to think, oh, if we get chance, we can speak without wire, without network anywhere. Now you have mobiles. So now we think like, okay, it is very difficult to go on moon. Maybe tomorrow your vacations may be on with your kids. You may go on moon and come back. Okay, this time we are going on moon. Next time we may go to Mars or Venus. It will happen. So for that, you have to work. Correct? So is it all good thing or we have challenges also? What are our challenges? We don't have the solutions for heart attack and cancer, diseases like heart attack and cancer. Our farmers are doing suicide because there is because there is flood and drought. There are natural calamities in which many lives are getting lost. Then still the manual scavenging has not stopped. We are telling we are developed country or we are developing country, but still people have to do the manual scavenging. Poverty and malnutrition is also there. Whatever we are getting in the developed cities, still that facilities are not reaching to villages. So these are the challenges in front of India. So can we do anything? What can we do? Whether we should be happy or we should be sad that we have these challenges? Sad. Sure. According to me, we should be very happy. Why? Because we have so many problems. When we have problems, see if exam is there and you are not prepared, what you people will do? Shortcuts. You will think like, okay, this question may come, I will answer in this way, yes or no? Actually, you should study fully, but if in 11th hour you will not be able to do, then you will do the shortcut method. You will think something else which can give you marks, yes? Temporarily you will pass. It is not a good example, but that time you will, okay, that subject is over. Is it right? So what happens is when you have too many challenges and you know you get you don't have any solution, then your brain starts working. Okay, I have to do something. What is it? Do we need any degree for innovations? Do we really need any degree? No. Why? Because what is the thing? Tell me when we need is the creativity, correct. So we don't need any degrees. We can think of many problems. When we have many problems, we will get many opportunities to solve those problems. So we can do innovation or invention both based on why we should be happy, because some countries are already developed countries, already they are very rich. We don't have money. We have to do adjustments in available resources. So we think differently. So that is very advantageous for us, because those countries which are not developed, they see as towards India as the leader country. Okay, India can give the solution. Because foreign countries can't even think of what problems we are facing. It is very different problem, very unique problems we face. So we think differently and we get unique solutions. So that is the advantage of problems. So as Joe Dispenza said, we are confined to our lives only by beliefs of our own, only by limits of our own beliefs. Do you agree with this? Yes or no? You can find solutions. If problem is there, then only you will think and you will find solutions. So you have tremendous opportunities to solve the problems. But we know how is our economy? We are intelligent. We believe, all of us tell that Indians are very intelligent. But how is our economy? Can you tell? Are we as rich as Western countries? No. We have so many problems. We are financially not that developed. Then do we have to solve our problems, or we should study space? Space is a costly affair. It is not, if you see the launch costs and all, it is in crores. Whether we should spend money on space or we should solve our problems. Why we should go to space? To solve? Why? Tell me, do you feel that why we should go to any new field? Forget about space, any new field. Why we should study?
Possible exploration of materials or isotopes which may help in solving the problems.
Good. So we have to explore. We are there at some point. We just should not think what the next person is troubling. We have to think beyond that, where we are. Okay, so first thing is, where exactly we fit in the vast universe. Correct? Okay, I am showing this picture. Can you tell me what it is? Can anyone tell me what it is? Okay, tell. Yes. What is this?
Are they groups of galaxies?
Galaxies?
Yeah.
All are galaxies?
No, like the group of galaxies.
Okay, good. See, right now where are we? We are in auditorium of Gopalan International School. Where is Gopalan International School? In Puri. Where is Puri? In Bangalore. Where is Bangalore? In India. Where is India? India is one of the country on the earth. Can we tell like that? Okay. So Earth is one of the planet in our solar system. Where is solar system? Solar system is in Milky Way galaxy. Where Milky Way galaxy comes? Milky Way galaxy is in the local group where many galaxies are there. Can you tell other galaxy? One galaxy all of you will know. Yeah. So local group includes many galaxies like Milky Way galaxy and Andromeda galaxy. Virgo supercluster we have. Okay. When you say where we are, where is Earth in the Milky Way galaxy or our solar system in the Milky Way galaxy?
On the exterior fields of the fourth arm.
Which arm? What is the name?
It's the fourth arm of the.
Good. It is Orion arm. Come here, take it. So our Milky Way galaxy is every galaxy shape you elliptical shape like a fan, correct? So galactic center will be there and all galaxies are around that center. So our Milky Way galaxy is near about 26,000 to 27,000 light years away from the galactic center. Okay, then comes the Virgo supercluster which has many local groups. Then comes Laniakea supercluster. Then comes the overall observable universe which with James Webb telescope, whatever we can see or beyond that, whatever is the aura. So this is our human mankind's cosmic address is this. Like you give your home address, this is our cosmic address for mankind. Okay. Now next thing is how is universe formed? Correct. Can you tell what Big Bang is? Yeah.
Big Bang is when the universe had infinite density and zero volume, and then it suddenly expanded into like plasma, and then came helium and hydrogen atoms.
Okay.
And then keep expanding and
Yes. Big Bang is not established, but Big Bang is a theory which tells us how universe is formed. Then our human being basically what happened, who came, why it came, we are very curious. So why we should go to space? Because we have the curiosity of knowing about the unknowns. We also want to know whether people like us are there on the other planets or is there any life in the other universe or other galaxies. Next one is spin-in and spin-off technologies. Spin-in and spin-off means what? If you are working in any field, or now I will get specifically about space. If you are on Earth and you are using, suppose your laptop or pen drive you are using, whether that I can use in space, that is called spin-in technology. You already know some technology and that you are using in the new developing technology. So that is the spin-in. We are using the available thing. And spin-off technology is when you are researching something, when what happened, any problem, I am hearing some noise. No, I am not angry. If you have question, you can ask, but you should not talk. You can answer. Okay, what is spin-off technology? Spin-off is whatever we find in space when we are developing something for space, whether we can use it on Earth. Is there something different? For example, the rocket coatings we are using in motor industries, or the tracking mechanisms that we use in space are now used for inventing or searching for the cracks in the tiles. And our space suits, have you seen space suits? So that space suit technology is actually used for incubators. Am I going too high? Are you getting what I am saying? Sure? Madam, is it okay? Means, sure, no? You can ask or you can tell me if you don't understand anything, I will explain. And the big picture thinking. What is big picture thinking? You have to think beyond what you are in that. If you remember John Maxwell's statement, if you are in the frame, you cannot see what is there in the frame. What is so you have to come out of yourself and think for future what you can do. So for that big picture thinking, we should go to space. So if we start with ISRO's Space Odyssey, who is this person? Yes, green shirt.
Vikram Sarabhai.
He is known as father of
ISRO.
Indian space missions. ISRO is dream planet of Dr. Vikram Sarabhai. Okay, when it started in 1969, for 6 decades, if we see, the hallmark is spectacular growth with limited resources, very limited resources we had. And he is the person who saw that satellites can bring total change in India. So he started the space industry or space activities in India. Initially we had 2 programs. You might not have been, are you aware of SITE and STEP programs? Have you heard of SITE and STEP? Okay, SITE is initially, before starting Aryabhatta, first he developed one ground antenna which can receive the signal. We were not having satellites that time. So first it was signals were received that satellite instructional television program that came in India, which was very useful for rural areas teaching. So that was the first experiment that got some, I think, noticeable in 1970s, that got some award also for big mass communication program in India or in overall world, not India. After that, state program was there. There also, when with the satellite, with the help of satellite, how television can reach at different places, how you can teach teachers in the remote places. That program started, and that was backbone. That site and step was the backbone for our India's satellite systems, INSAT systems. So when INSAT, because now everything started with INSAT, with that site and step program, and then we started with our own indigenous technologies. And this is our first satellite, Aryabhatta. With Aryabhatta, we started actually technically developing satellite in India. This is our first satellite. Then parallelly, satellite was not enough. So parallelly, satellite launch vehicles were there. In 1980, one SLV-3 was developed, and on that Rohini satellite was launched. Then came, this is Polar satellite launch vehicle. Many IRS satellites were launched with that, and then came geostationary satellite launch vehicle. And this was the geostationary satellites that are launched. Now we'll go, these are the, actually our usual journey from ISRO, from start to actually settling, like we are able to get something back from invested money. So this is the journey. But if you tap at some of the famous achievements, can you tell me? First was Chandrayaan-1, when it was launched?
I have a question. It's about white space. It's about white space. Why the research on space? Don't you think there are more pressing matters to be looking at, especially in a country like India where we can be
Slowly.
Don't you think we have more pressing matters that we should address, like poverty, the overpopulation, child marriage, child abuse, harassment, rape, etc., etc.?
How do you ensure that without doing space research we can solve these problems?
I mean, the amount of money we put into space can be used in these pressing matters.
I got it. Your question, I got it. It is very well thought of. Now you tell me that if now you invent something, are you sure that at a remote place of Africa, you are able to send your doctor or you are able to send your treatment without going there, without inventing or without researching in space? Or whether without mobile, when a person gets heart attack, whether your doctor will know that someone needs ambulance?
I mean, yes, there are technological developments.
It is not technological. Without space, it is not possible. So we should not restrict that. Oh, because here poverty is there, we will not do space research also, and will not solve poverty also. Both things are equally important. But we have to think further. Today you may be feeling space is not required or space is not. But when you are as I already said, if we don't need space, whether we will go for space suits? No. Then are you okay with living that young life to die?
I mean, with the amount of money we're putting, shouldn't we see more progress?
Because returns are there. You may see only the money. You are not seeing the returns. You see the returns, you will. Have you heard about Mom Mission Hour where that it is less than Hollywood movie? Have you heard about it? No. Read about it. About Mars orbital mission, with how much amount they have done. It is one of the. It is in the budget of one of the Hollywood movie. So only India can do it.
So it's
Mars orbital mission, MOM. Okay, mission to Mars. Okay, I'll come to that. That is the next mission. Okay, tell me.
Yeah, that's all. Thank you.
Are you convinced?
Yes.
Sure. No, you read about it. I liked your question. But see, that was the thing what I told, thinking big picture. If you are seeing today's problem, but our 50 years after now, problems are very different. That time again you cannot remain poor in that thing also. Technologically poor also is equally bad. So we have to think big. We have to go forward. Yes. So, okay, so first mission which you got recognition on when you started feeling ISRO is doing something in Chandrayaan-1. Chandrayaan-1 had one payload which was on the moon. That is our first step on the moon, which fell on the moon. Directly we have not landed on moon, but we went till moon. MIP payload, which was with Abdul Kalam's, late President Dr. Abdul Kalam's name was there on that, and Indian flag was there. So Chandrayaan-1 was launched in 2008. This is one of the famous mission. This I was talking about. What is your name? Sudipti, come take one thing. This is the Mars mission. What I was talking. Go and read about it. This is India reached Mars in 2013 that this was launched, and it reached the Mars orbit in 2014. Then one of the achievement was with the PSLV rocket. In single stage, we have launched 104 satellites. This was also world record. And it is not that useless satellite just launched. Each of these satellites is getting used. And that includes foreign satellites also. So again your question I am answering, Sudipti. There we are getting money with that. Our launch vehicle is launching foreign satellites. So it is a business. It is improving India's economy also. Okay. Then came first in 2019, Chandrayaan-2 was there. It was partially successful. And in 2023, we started what was the date? Anyone remember when it launched? When it got launched, not the landing date. Landing date is today's date. 14 July 2023, Chandrayaan-3 was launched and it reached the moon on today's day 2 years back. That's why we are celebrating this National Space Day. Okay. I'll tell you the story, it is very nice. And now all eyes are on the Gaganyaan mission, where we want to give our own indigenous spacecraft and our own Indian team reaching to space. Okay, so that is the prestigious Gaganyaan mission. So this is about ISRO Space Odyssey. Then, okay, we are on Earth. What are the advantages of being on Earth? We have, who is that? Very good, come here, take it. We have atmosphere. What is the use of atmosphere? It protects us from? Only radiation. It protects us from? UV rays, not atmosphere. UV rays is stratosphere. Then we have magnetosphere also. What it does? Correct, Shabas. It is deflecting the solar flares from, or any magnetic or solar flares only mainly. It is deflecting and it is avoiding it. We are safe. We are in safe zone. Earth's gravity. We are not floating. Earth's gravity is advantage of being on Earth. We have climate. We have water. Correct? Can you imagine if atmosphere is not there? Or we have our forest. Forest act as lungs for Earth. Is it right? It will take carbon dioxide and it will release oxygen. So we are very, what do you say? We are very happy and everything, all comforts are there for us. Is it right? And where is the Earth position in the Milky Way galaxy? Earth is said to be in the Goldilocks zone. Tell.
I wanted to ask like Sudipti said just now, you mentioned all of these space station research missions, which is very good for India itself, but why do you think we should explore space more than we explore our own planet? Because from what I know, we have barely explored our oceans, and we've only done 14 kilometers or so.
I'm not able to hear you, maybe. Can you keep quiet, please? He's asking something.
Why do you think we should explore space, but we should not explore the planet first? Because our planet we have barely explored the planet itself. Because we've only done 14 kilometers deep into the Earth's surface. We've only gone around, I think,
8 kilometers into the ocean, barely know anything about our ocean. So why do you think we should go to Mars before we go to the bottom of the ocean?
No, I don't think we should go to Mars and we should not see our oceans. Actually, it's your age. You have to. We are already in ocean. You know, one ocean spacecraft also is coming. Ocean monitoring will be done in soon. We should explore everything. It is not restricted to space. We should explore everything, and we should explore Earth. But it is it not? Don't you feel that it is? At least you know that life is only on Earth. Are you sure about it? No? Why? Then what? How you will ensure that life is not there on other planets?
That is fine, but in this...
No, planets are not fine, I'll tell you. Do you know that Venus and Earth were same?
Yeah,
You heard. What is Venus called?
I'm not sure.
Evil Kid, right? Are you aware of this?
Yeah.
So Venus was also exactly same as Earth. All the things. But can you right now go on Venus?
No, right, not right.
Why?
High pressure, extremely hot atmosphere.
No,
dense gas
there
clouds.
is no atmosphere. There is acid rain is there on Venus.
Yeah.
Okay. Then greenhouse effect due to that temperature is very high. Though we say Venus is very good and look wise we always feel Venus is very peaceful thing, but it is very hot planet. Life cannot survive on that. Do you agree with that?
Yeah.
Then, when we want to live on Earth, we have to retain our Earth as it is. No? It should be giving the life. We should not make mistake what might have happened on Venus.
Yeah.
So for that we have to explore other things also. It is not that we should not learn Earth. We have to learn Earth, but we should be aware of surroundings also. Surrounding in terms of galaxies and planets and all. Okay. Agreed? No?
Yes, yes.
Okay. Good. Okay, after some days you will enjoy. Once you learn things of why we are learning, once you know Earth fully, because we are aware better, we already know that the research on Earth is going on, so we have to go parallelly to space also. You will learn that it is going on and we have to explore that also. And maybe you will invent something else. So that is possible. Okay? So space environment, what I was telling is we are very happy on Earth, but when we want to go to space environment is totally different. Space is having vacuum. Can you breathe in vacuum? What is vacuum? No air, no atmosphere. Shabas, particles, come here. Okay, so particles are there. Then there is no gravity. Microgravity means what? We will be floating there. Now, if you are, I don't have to hold, that is a happy thing. I don't have to hold mic, but it will not stay here. It will come to you also. So that is not useful. We have to be, our Earth's gravity is not only for us on standing. Our atmosphere also is, because of Earth's gravity, it is on proper place. Correct? Moon's gravity helps in keeping the tilt of Earth and our seasons properly, right? This you might have learned in your geography. Correct? So, space is having microgravity, which is not good when we consider of life or when we want to go in space or when we want to design something for space. Other thing is radiation. As you already told, radiation is harmful for human beings, we know. But radiation is harmful for components also. Radiation is harmful for whatever electronics works in space also. So, do you know about memories or digital electronics? Any senior 10th standard or some? Do you know about digital electronics? Or memories? Memory in phone? Computer memory? RAM. No? Okay. So, due to radiations, what happens is electronics will not work. There can be bit flips. Means, suppose if I program like when I give one pattern, you should stand. When I give other pattern, you should sit. But if that bit flip happens, you will not stand. You will continuously sit only because actually I am sending command for standing. But you are always command that is going because of that failure is you will be always sitting. So that kind of problems come. So we have to take care when we design the space related equipments. Then next is space debris and micrometeorites. Why space debris happens? When there is no space, tell me, you know? Space.
In space, if there's ever any debris or any particle of anything, because it is a vacuum and there's so much empty space, it can go pretty much infinitely, and so it can move infinitely.
You say that space is not having debris?
No, I'm saying that it does have debris, but because there's so less and so empty, and there's very few things in the universe, it can move for a very long space. It can move for a very long time.
So space debris is less, you feel?
No, I'm saying it's more.
It's more.
Yeah.
Due to?
Due to that, because there's so less things for it to like clash and hit to it.
Okay. Okay. Any other answer? No? Okay.
It's usually caused by collisions of objects, and, as you said, because there's nothing to slow them down, right? There's nothing to
Slow you are saying?
as in, there's nothing to slow the space debris down, right? So nothing to impede the path. So basically, it just
Collision of what? That is my question.
collision of just objects in space itself.
What objects?
Because there's no force of retardation, like any objects, let's say asteroids, debris.
We will not go in the, I don't know much physics. I'm electronics, but I am not very good in physics. What I am telling is we will launch something. When we launch something, rockets will go up. Okay, so rockets will take the satellite to orbit. And then last stage, have you seen launches on TV? You'll be seeing launches on TV? No? When rocket goes to space, it will leave the satellite there, and the rocket stages, once it burns, it will come down. That causes your collisions, and that scatters everywhere in the space, and that creates space debris. Why that is risky? Why that space debris?
Because space debris are created by gravity in space, and since there's no air in space, there's no friction to slow the debris down. But in planets, there's air resistance to the force that's generated by the objects would not hit into each other. And because of the vacuum, they keep colliding because even more smaller particles which float away and cause destruction.
Correct. But the you can take if you want. Very few things remain, you can take. Okay. So the problem with this debris is actually, if you see our what is our car speed when you are coming to school, or your bus speed approximately 60 kilometers per hour, 100. How much it is? Driver drives fast, slow, 40 kilometers per hour. So if you take one of the spacecraft that orbits in the speed of 7.6 kilometers per second, so you can think of actual speed. Now with that speed, you know gun. This is also a bad example, but sorry. What is the speed of gun? Why person dies because of pistol or gun? You know? Okay, actually the effect is due to speed. Do you agree that much of speed, with that much of speed, that gun comes to the bullseye, so that gets hit correctly. Correct, no? So in space also, that much is the speed, and with that even small particle with that speed, when it hits, it becomes a very big impact, and it can spoil spacecraft. So we will, you are telling now, why I was also initially telling it is a costly affair. We will build something of crores, but with a minor particle in the space, with that speed, it will spoil the spacecraft. So we have to take care, if it happens, how we can avoid it. So that is one more thing. Then upper atmospheric drag is there, due to which we have to continuously maintain. And temperature extremes. Can you tell why temperature extremes are there in space? No, you are holding on to particles only. Go ahead.
There's no particles, so there can't be any heat in space. That's why it's like.
Which heat is not there? Which heat dissipation or how we cannot? What is not there? Conduction, convection, radiation.
Yeah, conduction and convection.
Okay. Convection is not there. Yeah. Convection, correct, no?
So yeah, so it'll be like freezing temperatures.
Okay. Other things, yeah, you want to tell something?
Basically, because there's no particles to collide for conduction, heat is not dissipated properly. So when the sun's radiation hits you, on one side it'll be hot because
Yeah,
there's no
yes.
radiation, and on the other side it'll be cool because there's no radiation. And heat does not dissipate properly, so you get temperature extremes on one side.
Okay. Here one side, other side there is very correct. When satellite is directly facing sun. When satellite faces sun, it is very high temperature. Though it is not near, it will be in the more than 100 degrees centigrade. When it goes beyond the earth, you have studied eclipses. When it goes beyond the earth, there is an eclipse. So it will be in very cold space of -100, -120 or some degrees. So satellite has to, and continuously it has to rotate. One satellite in a day, it will make 16 rotations on earth if you take IRS satellites. If you remember Sunita Williams, you have heard of? Now you tell parts. I told spacecraft. Okay. When you say space starts, I am telling spacecraft. Why aircraft cannot go? Why car cannot go to space? Okay, this said anyway.
Because most vehicles can't sustain escape velocity and they can't escape Earth's gravity to go into space.
Okay, correct. My question is where space starts.
Space starts at the Kármán line, which is roughly about 100 kilometers above from the Earth's surface.
Why it is 100 kilometers?
That's about the end of the atmosphere.
That is end of the atmosphere. So, do you say that exactly I measure 100 kilometer atmosphere is zero and outer space starts?
No.
No, there is a imaginary line from the scientist Kármán. We tell that there is a imaginary. You want to say something?
Yeah. Space starts from the exosphere of the Earth.
No, space starts where atmosphere ends.
Yeah, exosphere ends there. So, exosphere ends there. That's
Atmosphere ends. That is Kármán line. That comes at 100 kilometers. From sea level, if you take 100 kilometers, we say that Kármán line starts. Why do we say 100 kilometers? Why not 105 or why not 95 kilometers?
it's the average that's taken. It's the average that was taken.
No, it is not average taken. At 100 kilometers approximately, our aircraft flies on based on airlift, correct? Airlift. So after 100 kilometer, aircraft will not have that lift. Your aircraft cannot fly in the air because that much of air pressure cannot be built because atmosphere becomes less dense. Okay, atmosphere, that much atmosphere is not there, that density of atmosphere is not there, so aircraft cannot fly at that rate. There we need spacecraft. So to develop or to send the spacecraft to space, spacecraft cannot go unless until it is a single stage, it cannot go directly to space. We need other things. So these are the different parts of spacecraft. First one we already saw, it is a launcher. So or launch vehicle, which we call Diwali rockets. Correct? So what it will do, it will place the spacecraft based on the requirement. You want to go to geosynchronous orbit, you want to go to geostation. Have you learned about orbits?
Yes.
You have learned which standard?
9.
9. All of you know about orbits? Okay, you have 2 orbits or 3 orbits?
Oh, what?
How many orbits you have? When we want to launch spacecraft or rocket?
3.
3. Which are those? Okay, we'll see that. Sit. Okay. So we can go with the launch vehicle, is geosynchronous, geostationary or polar orbits. Polar is when you want to put the rocket spacecraft in on poles, polar orbit. Okay. The spacecraft is actually relay station in space. We are designing it based on application. What are the applications? Whether we want to use it for communication, whether we want to use it for weather forecasting, or whether we want to use it for some application for scientific research. This is the spacecraft which gets launched by rocket. Now rocket, spacecraft is payload. For spacecraft, whatever is our actual application, whether you want to develop it for farmers, whether you want to develop it for earth observation, or whether you want to develop it for scientific research. So those are called payloads. Payloads can be communication payload, remote sensing payload, or scientific payload. Can you give me example? Communication payload, our television. Remote sensing payload, they will tell the so remote sensing payloads are for the meteorological applications, and scientific payloads are for research or for knowing the new things that we develop spacecrafts. And though the ground segment, when we say it is not for, actually it is not a space element, but these are required because we have to test the spacecrafts on ground. Okay? So when we have to go for spacecraft designs, how we can design spacecraft? There are design drivers, environmental constraints, and design constraints. Design drivers are for what application we are developing. What is the mission objective? You want to develop satellites for farmers, you want to develop satellites for medicine, telecommunication, telemedicine. Based on that, it will be decided what orbit, what is the launcher, what is the rocket, and what will be the spacecraft configuration. Then environmental constraints, we have already seen what is the space environment. So when we design the things, we have to see about the space environmentals. And design constraints are, it is as already said, it is, see, we have to launch it, and there is no, in space we cannot repair. Also we have to take it to more than 100 kilometers far above the atmosphere. So we have to think about how much power is available, very less weight should be there, very less volume should be there. And if it fails, it should not, because we are spending so much money, it should work also in future. So if it fails, we should be having some redundancy. Even some part fails, it should not be total mission failure. We should have redundancy also. So these are the spacecraft orbits which I was telling. So if you take these main are three orbits. One is this geostationary orbit, one will be highly elliptical orbit, and the orbits on polar, synchronous or polar orbits. And this is the inclination. This one, if you see, this is the geostationary orbit, and these orbits can be inclined orbits also. So mainly eccentricity of spacecraft, eccentricity of the orbit, and type of orbit and inclination will decide what your spacecraft will see. Means if you are sitting in the theater, whether you are sitting in front, whether you are sitting on the left, whether you are sitting on the right, based on that your view will be different. So like wherever we are sending the satellite, what it will do depends on its location in space. So now we'll come to basic satellite communication. Satellite communication is, first from ground we will be uplinking and transmitting the desired signal. There will be a ground station. That uplink satellite will take the input of the uplink, it amplifies the signal, it filters the noise, and then it will send the signal to different part of world, and the receiving station or ground station will receive the signal. That way our television or any communication works in that. You might have seen the TV reporters coming with the small dish antenna, and they will be taking the report, and that will be with small bus, they will be sending to the destination wherever on, or on our TVs also. So what are different subsystems? If you want to design a satellite, it is not single subsystem. So we will be having different subsystems. If we compare it with our body parts, like we say brain is important, but can brain work without skull? It is not possible. So whatever delicate systems you are developing, that should have some protection. So that is the function of the structure. Structure will keep all the systems together, and it will protect the system. Then like for our life, we need food for living, correct, no? And food is coming from plants, trees, from photosynthesis. So like that, the systems that are working in spacecraft are dependent on electricity, electronics, or it needs power, electricity that is generated by the panels, solar panels. And solar panel will save the electricity in the battery, and that is used by the spacecraft. Communication is like our telephone, where what we are speaking, we will be giving command to spacecraft, and spacecraft will be working accordingly. Now how we will say that spacecraft has, suppose I want to take image of this hall. How I can tell the spacecraft that you take the image here? Spacecraft has to be oriented in particular direction. Spacecraft should be in particular orbit. So that is the function of this attitude and orbit control system. We will be pointing in a specific direction, and then we will get the specific data required or desired data required. For that we need to set the telecommands and telemetry. And as I said, there are thermal environment, thermal cycle, and electronics works in specific temperatures only. So we have to go for we have to maintain the temperature, that is done by the thermal system. And we have seen that there is atmospheric drag, so that will pull the spacecraft down. We have to maintain the spacecraft in particular orbit. So whenever due to drag, when the spacecraft is coming down, it will be, propulsion system will be used to keep it in proper orbit. So what are the applications? We have almost seen all the applications in there. Broadcast services we know, weather forecasting. Can you see what applications are there? Weather forecasting is there, earth observation is there. For military satellite, for strategic purposes, we will be using the satellites. Then navigation satellites, we have MapMyIndia, Navic satellite, Navic constellation. Then we have mobile communication. I am not telling about mobiles that we use, satellite communications. In disaster, when mobile towers itself are not there, that time satellite communication is used. Then telemedicine and tele-education is there, disaster management is there, and for astronomy also, spacecrafts are used. Now coming to the Chandrayaan 3. Today is National Space Day, which is celebrated due to Chandrayaan 3's launch. So Chandrayaan 3 was third lunar mission of India, and the goal was soft landing on moon and deploying the rover to conduct scientific experiments. So how it went? Chandrayaan 3 went from Earth to moon. Okay, here if you see, this is our Earth. We started from here. We wanted to send the spacecraft to moon on this side. So these are called the actually trajectory for the from Earth to moon. So first the spacecraft is in the parking orbit, temporary orbit to start with, and then it has to escape the Earth's gravity. So what it will be done? The spacecraft will be fired at this end, and slowly with each burn we will be increasing the orbit of the spacecraft, and finally at the last burn the spacecraft will leave Earth's gravity, and then it will start going to moon. This is called the lunar transfer trajectory. Once it reaches the lunar orbit insertion, there we will be going to perform the retrobursts. Here it will be actually first going through large orbit, and then slowly it will come down near to moon as with retrobursts. Near to moon it will be coming near about in the 100 by 100 orbit. Then the deorbiting maneuvers are performed, and then after the deorbiting maneuvers, it will come close to the moon and slowly it will land. Is this clear? Because on this slide, next slide is dependent. You understood everything? Okay. So the aim of Chandrayaan 3 was soft landing in South Polar region. Why South Polar region? Because it is having so many craters and mountains, and it is said that it is having the water in the form of ice. So we want to check whether we can survive or whether there is a water on moon surface. So specifically South Polar region is selected for landing, and these are different landing phases. Now if you see from again I will tell you the example from car. If you are coming to a dead end, you will first put, can you keep quiet please? Okay, when you are driving in car with a fast speed and when you want to turn, right turn, 90-degree turn, that time you have to suddenly slow down. That is called this first phase, rough braking phase. We are in the orbit of 25 km near about, and from there we have to come to close to moon because we cannot suddenly land. So we will be coming from 30 kilometers. These numbers may not be right. Please don't take photo for this particular slide. So this braking will be there, and it will come to attitude hold phase. It will be from 25 kilometers, it will come to near about 7.8 kilometers or so. There they will be checking whether the attitude is correct, whether the lunar land is plane. It is lunar, moon also is flat, not flat line. It is like Earth only, spherical. So first it will be checked whether we can land on this. Then attitude hold phase, after checking, it will slowly orient the spacecraft and it will make it straight for landing. Then there will be a fine braking phase. In fine braking phase, it will hover over the moon's surface, and then after all the payloads and after all the sensors are checked, it will be decided to land on the moon, and the final descent phase with a speed of 1 meter per second, it will land on moon. So this is actually the lander. If you see, this is the lander. This is the propulsion module of Chandrayaan 3. And what were the payloads? These are the lander payloads. One is for the Ramba is a Langmuir probe. Then I think here I have indicated the payloads are here. If you can see, if you can read it clearly. These are the payloads. There is Ramba payload for with Langmuir probe. Chastity is for temperature changes. ILSA is lunar seismic activity, whether like we have earthquakes, whether moon also is having any moonquakes. To study that, ILSA payload is there. Then there are two payloads on rover also, which is one is with the X-ray we are checking with the component, elemental components, that is APXS and LIMS payload. And the propulsion module which I showed previously is having this shape payload. It will see for the Earth's status. Now next one, I have taken only 3 spacecrafts. One is Chandrayaan, just all scientific because communication and IRS is common thing. Aditya L1 is for solar coronal ejection, coronal CME activity. Okay, so here are, these are the payloads who are remote sensing payloads, VELC and SHOOT payload, and other ones are can you anyone again tell me what is the Lagrange point?
I have a question.
Tell.
About Chandrayaan 3, it's the first mission that's landed on the south side of the moon, right?
Yes.
Why haven't other countries or other missions done that? And why have they only landed on the north side? What's like the...
Because our scientists felt that it is a, first thing is first time. Second thing is there is a water possibility of getting water on the that side because mountains and craters on the south side, it is rarely explored thing. Some moon, see whenever this some global activities happen, it will be for the global interest, global scientific interest, not for only India. So already what is there on other side of moon is done by some of the countries. So we can explore this side where no one has gone. And some useful thing, you know that finding of sulfur is there. So some useful thing we can get on this side. That's why it is decided on.
I mean, there have been other missions on the north side. There have been multiple missions to the north side of the moon. Why haven't those countries or those missions taken an initiative to go to the south side?
Not understood.
Is there a need?
Can you please keep quiet? She is asking something.
Is there some difficulty to go to the south side? Because most countries, they've gone to
See,
the concept
there
of-
will not be any difficulty. The thing is, anything you are doing first time, there are so many unknowns. And because the cost, efforts, everything involved, we have to make sure that 100% we can go there. Then, and still failures will be there because there are so many unknown things involved. The difficulties, even starting from here, the launch itself is a challenging thing. So difficulties will be there, but because we have wanted to explore something, we have tried doing that after studying the thing. You know, this Chandrayaan 2 failed, you know. So Chandrayaan 2 failed in particular thing only. Chandrayaan 2's orbiter was there that took photos of South region that told where Chandrayaan 3 should land. Then only we are landing on that. So we have seen that it is safe enough to land and then only that was activated. So it is just exploration where we can go and what useful we can find. Thank you. So one more mission is find the.
Excuse me, ma'am. Sorry to interrupt you. Why do other countries aim to go to the north region? Is there any significance to that?
Why other countries?
Ma'am, the other missions which various countries have undertaken, not one had gone to the south region and you've justified that, ma'am. But why do they go particularly to the north region?
Because it was easy to go first on the other region. That is safer thing for the less craters, less both like mountains and valleys are less on that side. They felt it safe, so they landed it there.
Ma'am, meaning like reason as to why we went there is due to the craters and possibility of the water being found in ice. Is there anything special in the north side just like that?
Special on south side is that only that we felt that by the research like water in the form of ice we may find it there because shadow is there with great mountains. So it is thought that it will be there, so they have decided.
Excuse me. Ma'am, I have a doubt. The main objective was to land on the dark side of the moon. So what was the purpose of that? Anything we find on the dark side, wouldn't it be the same there as in landing on the same side? So wouldn't it just be a waste of resources to travel all the way around?
No, because you cannot say waste of resources. We are here to generate or search or get some new scientific data. With some good thought only, it is decided to go on south side. We have some inputs from north side thing or water on the moon side where other other space agencies has already landed. We wanted to explore this side because we felt there are some important or useful things from further future moon missions. So we have explored the south region.
So was there anything new that was found on the south side or was it just the same as the other?
I have not got your question.
For the purpose, landing on the back side, which was not done by any other country, did we find anything different or was it the same?
Yes, we have many findings and if you go to ISRO's website and see the scientific data available, you will get what all findings are there and still it is in progress only. We will be getting many other things also. Many payloads have found the elemental composition. There are temperature differences, how we will be surviving if at all we are planning to. We have future lunar missions, how we will be, that input data we are getting from the scientific payloads on the south side.
Thank you, ma'am.
So next, okay, this I told. Now see here, what is the use of this directly? I will tell. Aditya mission, why we have to go to sun? One thing is.
Ma'am, is it possible for the space turning into a military line? Nations to extend their area using space.
I heard only using space. What is your question?
Is it possible for space turning into a military line? Nations using space area to extend their nations.
Nations using space. Can you tell this question, please?
Ma'am, nation to extend their area using space.
Nation to extend. Exchange. What is it? Huh? Extend the space for what reason?
Ma'am, using space as a defense. Using for.
Okay, we will not go in that zone. I understood. You want to say the what you say, splicing of moon for different countries. That way you are asking?
Yes, ma'am.
Okay, it is not like that. We are not owning or we are not considering anything in that. It is not. That is not our zone. We are scientists. We have to work and we have to find out what political thing goes or who will go. We are on the betterment of mankind, not for any country or any person. Okay? And you also should become like that only. That is some other person's job to do, distribute, divide. I showed you the cosmic address, so you have to think about the cosmic address, not about moon or not about earth, or who is owning that. Okay?
Ma'am, I have a doubt. Why doesn't India or any other country, in fact, do any more manned lunar missions? Even though we have the resources, the money. So why don't we do any manned lunar mission?
First we have to enter the space. Okay? After entering the space, our human being should go to space. We are in that stage right now. Definitely, manned mission for moon will be there in future. First we will go, first we will land, Gaganyaan first will go in space, how people will go in space. Then they will try to go on moon, then they will try to bring sample, then they will have many manned missions. Okay?
Okay, ma'am, but why like the last manned mission and the first one we did was in 1969 by the Apollo missions, the USA missions.
See, the space is very risky. When human life is involved, you have to think of hundreds, thousands of things. And it is not only costly, it is very, very risky because it is not only dependent on how you are designing or how you are doing. It is dependent on the fact, I told you about micrometeorites. After taking all the care, one small micrometeorite hits, it will make a big hole in the spacecraft. Then the person cannot survive because they are in the closed chamber. That should remain till they come back to correct oxygen pressurized chamber. That is very, very risky. So they all are going, but it is not so fast as we do it on Earth.
Now the technology has evolved like significantly in the past decade or so. So why are we not carrying out more manned?
Because we are seeing certain accidents, we are seeing that there are limitations, so we have to go ahead with utmost care. We don't want to lose any life. Life is precious than anything else. Okay?
Excuse me, ma'am. Ma'am, my name is Prachita from first PUC, and I am very interested regarding the space research. So, like, ma'am, we can see that many countries are trying to find very new things here, like in space. So, ma'am, what is the most valuable thing that we could discover in space through which the research can reach its peak?
What is the what thing in space?
Most valuable thing we could discover in space?
Everything. Right now I will say everything and anything. The thing that we know is already escalating and we have all the answers for it. But there are so many things in space to explore. Anything may be useful. You know that Earth is getting crowded. Someday you might have seen one movie is like something is hitting Earth and we may lose lives and there will not be any life. So in such a situation, after 1,000, 10,000 or many light years, if we want to go on another planet, we should be ready for. So everything is valuable if we want to save life. Okay?
Okay. Thank you, ma'am.
Okay. Sorry to interrupt. Children, we'll take the question answers. Probably we could, if you have any questions, you can just list it out and share it to us later. We will send it to ma'am as an email or something, because otherwise, we will just be extending the session. So we've had a lot of questions. In fact, it is really very heartening to know that so many of you have so many questions and are interested. But then we will finish the session for today after ma'am completes her slides, and then we'll take your questions as an email and forward it to ma'am. Is that fine?
Okay, no? Okay. So I was telling like I took one moon mission, one sun mission. Sun mission is important because there are solar flares which can affect our power grids, which can affect our communication, which can affect our health. if everything goes bad because of flares, that we have to study. So when we launch spacecrafts like Aditya, that we will get the information in advance and we can take care of our failures due to the solar flares. And other one is SpaceX mission. Here now who was telling that future what we are going to do. So SpaceX is find the other one and connect. That is the mission. So here two spacecrafts are there. One is called Chaser, other one is called Target. So it will be launched in the same orbit, means it is already launched in the same orbit, 20 kilometers apart, and that is called Far Rendezvous. And then slowly it is brought together and then they mate with each other and then together they will perform. That we are establishing the experience of docking. Why this is required? If we want to send a person on moon and bring him back, so first he has to land on moon and then he has to connect also, lift also. So that landing again connecting back to the orbiter needs the docking thing. So once docking is established, we can do the lunar sample mission or we can do our Bharatiya Antariksha station. Stage by stage we can go in the space and connect. For this kind of docking is important. Okay, so who makes this mission possible? Now, here 2 minutes I will divert from your technical things and I will tell you other things. When that Mars orbiter mission was going on, it was first launched in 2013. And why I am showing this is you can become anything and help space. Anything in the world you can become, whatever you are passionate about, whatever you are interested in, but still you can get connected to space if you are interested in. So when we launched Mars orbiter mission, it was launched in 2013 around November and it reached the Mars orbit in this 2014 September. So near about 300 days this cruise phase was there. For these 300 days, right from launch till the Mars orbit insertion, you might have heard Prime Minister telling, "Aaj Mangal ko Mao min gayi." That was so till that 300 days. Each and everyone, each engineer, like day and night, 24/7, they are working from the launch till it reached to the Mars orbit, and continuously they are working. They were working, and this was the success. Even the canteen, day and night, they were both duties were there, and they were very much dedicated way they were working, and it is not on. And it is not only the engineer or technician, canteen people, senior scientists, without thinking of their age or health, 18 hours they were discussing, thinking and working on that. Transport people, they were taking us day and night that this lunar burns or Mars burns when it comes to going to orbit. Each and everything is very important, so that everyone was taking care. And what I am telling is, success, individual success and team success is very different. Unless until you work in team, you will not get the success like this. And any large organization needs this kind of teamwork. You have to think beyond yourself, you have to think beyond comfort zones and work in the team form. Then only successes like this are visible. Even for Chandrayaan 3, if you take all people, is from that when it was launched 14 July till the landing day. One of my young colleague, in Chandrayaan 2 failed, we all were really very sad and very disturbed, like we were not expecting this. What that person did, younger like this only, in engineering college, just pass out. He kept the, that you might have seen that image of lander crashing on moon, which is now the point called as Tiranga. So he kept that image of lander crashing on moon on his screensaver, mobile screensaver. See how people think and how dedicated they are. He said, whenever I see this, I will know that something is missing and I have to work towards it. I will work towards it. From the Chandrayaan 2 failure till we did this successful Chandrayaan 3, all were totally dedicated to that. We have to make this mission successful. We have to make this mission successful. All this, whenever the day and night things were going on, even families were adjusting. Some had young kids, some were having some problems, some had ailing parents. No one was complaining about my exam, how I will do, I don't want to work there. Everyone was, no, we have to make this time, it should be successful, it should be successful. All senior scientists at the age of 65, 70, no one is totally happy, don't need, we are not having anything. Continuously they are thinking, okay, now next moment where each burn and each thing is critical, because every small change, it will lead to failure and we cannot do anything. So everything was taken care. Canteen people, when we are discussing in the rooms, canteen people will come in, madam, we have not had coffee for long time, I will give. We don't have to think about it. They are taking care. No, we are in this mission. We have to do it success. Transport person, madam, that third lamp burn happened. Whether it was successful this time, we are being on moon. No? That much dedication from every field was there, and then because of that, this success comes. So it is not 1%, 2%. Okay, when it landed on 23rd August, I think that evening it landed, and the whole India was ecstatic about that landing. We were there. We were very, very happy, everyone. But what catched my this thing was in the full happy mission room, there was one emotional sound. Somebody was calling, and it was like, Papa, hum chand pe pahunch gaye, Papa. And suddenly I felt a big void. Like how proud my parents would have been that I am in such a prestigious or such great success for India and for the whole world. Landing is not only for India. It is a success for world in scientific community, in space community. So how big it, how proud they might have been. I am telling you this is, you cannot celebrate any success or any great achievement without blessings of your parents, teachers, good wishes of your friends. So please remember that you have to really think about them. You have to thank them wholeheartedly what they are doing for you, how they are, show your affection now only, not like, okay, when I grow I will think of, okay, I will do something for you. Show your affection, show your respect to them. And always remember that not all are as privileged, as lucky or privileged as you. So you remember this thing, thank them really always whenever possible. It is really a good thing that you have parents who are affording and who are giving all the luxuries to you. Okay? So, next. Okay, these are, I will go fast. I will not speak on these things. I will just show you what all is there. For students. Yeah, tell me.
I just wanted to know what degree did you take up in your bachelor's that led you down this path?
You need not worry, you can take anything. Okay, I did electronics and telecommunication and instrumentation. Now I am working on biomedical, but you can take anything. In my work field is control electronics, but anything is useful. Anything you can take. And I think everything is important. I cannot tell that only electronics will be useful. Everything is important. So this slide you just take, go to, if at all you are interested in, you go to ISRO website, search on programs, you will get all the programs. The main aim, vision is harness, sustain and augment space technology for national development. At the same time, we have to pursue the space science research and planetary exploration. So these all programs, see IRST and IIRS are the Technical Institute, Indian Institute of Space Science and Technology, and IRS is Remote Sensing Center. And they provide all the degrees also, they conduct courses for kids also, online programs are available. You can go to the website, you will get those details if you are interested in. And Space Tutor is, NGOs can take the participation, NGOs can take lead and they can make their own comfortable course curriculum. They can tie up with ISRO and teach students what they need. It can be NGO, it can be school also. Then Space on VSS, you can, this is basically for the remote village areas. You can call ISRO's details, means technical details are on in the bus and they will come to your place in schools, villages and they will show you what all is there. Yuvika, are you aware of Yuvika? It is for 8th-9th standard students. Yuva Vigyani Karyakram. The main aim is catch them young. If you are interested in science, technology, engineering and mathematics, you can try for this questionnaire and enter and get the inputs and come to ISRO for getting training. Then Unnati is Unispace Nanosatellite Technology Program. They will actually teach you how to build the satellite, how to test and how to launch. This in Unnati foreign people are also involved. This is just for your information. For kids, it is not much of use. It is like any data if you want to see. This is available data sources from ISRO. So, as Prime Minister said, together we shall give a better future to the world and better world to the future. Thank you.
Thank you so much, ma'am, for your insightful session and for inspiring us with your words. Before we conclude today's session, we would like to share something special with you all. Dr. Rupali Abhyankar, wife of late Dr. Shantanu Abhyankar, in whose cherished memory this lecture series is being held, has sent us a recorded message to convey her vote of thanks to the school authorities.
Before
It is all
Madam starts her
listened
speech.
to her words with respect and warmth.
No, no, let's just hold. He will hold it. Thank you. Come sit down.
It's broken, bro.
Hello everyone. This is Dr. Rupali Abhyankar, an eye surgeon practicing in Gwalior district, Satara, Maharashtra. First and foremost, I would like to thank Dr. Anurag Lavhekar for being on the front foot in the organization of this lecture. My husband, Dr. Shantanu Abhyankar, was a person with a scientific temperament, an atheist, a famous writer, and a YouTuber. He truly thought it was his mission to develop a scientific attitude and a skeptical approach towards each piece of information in every student. He believed that such students would live a wonderful life full of scientific and rational thoughts, and they would be leagues away from superstition and wrong beliefs. I would like to thank Mrs. Rajashri Chaudhary ma'am, the Honorable Principal of Gopalan International School, Bangalore, Mrs. Sunita Prabhakaran, Director of the Gopalan Foundation, and Mr. Shripad Ghate, and once again Dr. Anurag Lavhekar for taking the initiative to conduct Dr. Shantanu Abhyankar Smruti Vyakhyan every year. I feel truly indebted to today's Chief Orator and Honorable ISRO Scientist, Mrs. Tanuja Patki, for agreeing to act as a luminous and guiding star for the students today. Would also like to thank all the teachers for developing a receptive mind in all the students and the wonderful students who are willing to change for the good. Would love to meet all of you in person someday. Thanks and bye for now.
Thank you, Dr. Rupali ma'am. We are truly grateful for this session. It is now my privilege to invite our esteemed principal to deliver the word of thanks.
Thank you, girls. Okay. The exploration of space will go ahead, whether we join it or not, and it is one of the great adventures of all time. Good afternoon, everyone. It is both an honor and a privilege for me as the principal of GR GIS to deliver the vote of thanks on this special occasion. At the outset, I would like to extend my heartfelt thanks to our management, Dr. Prabhakar sir, our General Secretary, and Ms. Sunita Prabhakar, our Director, for this opportunity and for their vision for always supporting the cause of student empowerment and growth. I extend my deepest gratitude to today's speaker, Ms. Tanuja Patki, scientist at ISRO, the esteemed scientist from ISRO Bangalore, for her gracious presence today and delivering such an inspiring and insightful session. We could see the amount of passion with which ma'am was speaking today, and that only goes to prove her work, her dedication and her contribution to the Indian space research. Thank you very much, ma'am. Your presence today, I'm sure, has truly inspired my students who have come here on a Saturday morning and sitting for the lecture on space research. Definitely, they have learned and will take home a lot of new vision and a lot of new dreams. Your presence today has been nothing short of a gift to my students. You have opened their minds to the wonders of space science, and your words have sown seeds of curiosity and ambition that I am confident will grow into great aspirations. Hearing firsthand about India's advancements in space technology from someone who plays a vital role in India's space missions has given them a rare glimpse into the hard work, dedication and innovation behind every satellite launch and mission. Thank you for sharing not only your knowledge, but also your passion, your experience and stories from ISRO. They have made science come alive in this hall today. I would also like to acknowledge and thank Dr. Lavekar from the Ninad Foundation for your efforts in educating, empowering and uplifting those who are often overlooked. Truly reflects the spirit of service and social responsibility. You are not only spreading awareness, you are shaping responsible citizens. A heartfelt thanks to Mr. Shripal Khate for giving GIS the opportunity to be a part of this initiative, especially for our students to get such an opportunity from a leading scientist from an organization which we as Indians and as Bangaloreans are very proud to be associated with. We are also thankful for Mr. Patki to be a part of today's session. I thank the principals of Gopalan PU College and Gopalan College of Engineering and also Dr. Manoj Chella for sending their students to be a part of this very enlightening session. I thank and appreciate the IGCSE team, the COD, Dhanya ma'am, exams officer Monica ma'am and the faculty for looking into the program order and ensuring all arrangements are made as per the requirements to put this event together seamlessly. And of course, a special thank you to our students. You were curious, you were attentive and asked questions that showed genuine engagement. A big round of applause for yourself, children. I'm really very proud of you for coming in today and for being a part of this session. It's only through these sessions, thank you, children. It's only through such sessions that whether you know anything about space research or for that matter any subject that we call people to talk to you about, this is an important opportunity for you to open up your horizons. It's important to know about other aspects, other fields, other professions. There is so much more that is there, that is open out there for you to explore. And these are initiatives taken by our school to just create or bring in that spark of curiosity within you so that you would explore other domains. I know most of you would be interested in specific things, but there is no harm or nothing to lose when you learn and when you open up to other professions or other subjects. So take each and every of such sessions as an opportunity to gain knowledge and to move forward. Thank you very much. Let this be the beginning, a spark that leads to more such interactions, more learnings, and perhaps in the future, even a few of you sitting there joining the ranks of scientists at ISRO. Once again, thank you all for your time, your presence, and your inspiration. Thank you.
Thank you, ma'am, for your thoughtful words. As we bring this wonderful session to a close, let us all remember that, like the astronomers and scientists at ISRO, who turn possibilities into realities, each one of us has the power to explore, discover, and create new horizons. May today's inspiration guide us to aim higher and shine brighter. Thank you, everyone. Let's keep dreaming, keep learning, and keep reaching for the stars.